below. In this lecture, we'll answer on two questions. In the first question, we find out the length of line segment X that is in rectangle ABCD. And in the second question, we'll find out the area of the green shape that is inside the semicircle. So we start with the first question. In the drawing, we have rectangle ABCD. Inside the rectangle, we have a circle. We know that the length of the tangent from point A to this circle is equal to 33 units. The length of the tangent from point D to this circle is equal to 35 units. The length of the tangent from point B to this circle is equal to 85 units, and our mission is to find out the length of the tangent from point C to this circle, that is equal to x. So we have to find out the value of x, or the length of the tangent from point C to this circle. So first of all, we will define the center of this circle as O. We will define the point of tendency of the tangent from point A to this circle as E. We will define the point of tendency of the tangent from point D to this circle as F. And we will define the point of tendency of the tangent from point C to this circle as T. And finally, we will define the tangent from point D to this circle as M. In the next step, we will join points O and E together by a straight line. Here, point O is the center of the circle, point E is the point on the circle itself, therefore OE is the radius of this circle that we will define as R. OE equals to R, and we have rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have tangent AB is tangent to this circle at point M, and we have the circle and the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, tangent AB will be perpendicular to the radius MO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to this rule, rule number 1. We can implement rule number 1 in our drawing. Why? Because in our drawing we have the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. Okay. Likewise, we join points O and M together by a straight line. Again, point O is the center of the circle, point M is the point on the circle itself. Therefore, OM is the radius of this circle that is equal to R. And we have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and F together by a straight line. Here, point O is the center of the circle, point F is the point on the circle itself. Therefore, OF is the radius of this circle that is equal to R, and we have the radius OF that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. And finally, we join points O and T together by a straight line. Again, point O is the center of the circle, point T is the point of the circle itself. Therefore, OT is the radius of the circle that is equal to R, and we have the radius OT that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. In the next step, we join points A and O together by a straight line. By joining points A and O, we created here the right triangle, triangle AOE. So we will implement the Pythagoras theorem on the right green triangle, triangle AOE. Okay, so according to the Pythagoras theorem, in the right green triangle, triangle AOE, by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AO, therefore the square of the hypotenuse is AO square, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to OE square plus AE square. Repeat again, in the right green triangle, triangle AOE, according to the Pythagoras theorem, AO square equals to OE square plus AE square. So AO square equals to OE square. OE is R, therefore OE square is R square plus AE square. AE equals to 33 units, therefore AE square is 33 square. So, in conclusion, according to equation number 1, we found out that here AO square equals to R square plus 33 square. In the next step, we will join points O and B together by a straight line. By joining points O and B, we actually created the right triangle, triangle OBF. So actually, we'll implement the Pythagoras theorem on the right yellow triangle, triangle OBF. According to the Pythagoras theorem, in the right yellow triangle, triangle OBF, by PT, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OB, therefore the square of the hypotenuse is OB square, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to OE square plus OB square, OE square plus FB square. Repeat again. According to the Pythagoras theorem, in the right yellow triangle, triangle OBF, OB square equals to OE square plus FB square. So OB square equals to OE square. OE is actually OF square. OB square equals to OF square plus FB square. Repeat again, OB square equals to OF square plus FB square. So OB square equals to OF square. OF equals to R, therefore OF square is R square plus FB square. FB equals to 85, therefore FB square is 85 square. So in conclusion, according to equation number 2, found out that OB square equals to R square plus 85 square. Okay. In the next step, we join points O and C together by a straight line. By joining points O and C, we created here the right triangle TOC. So we'll implement the Pythagoras theorem on the right orange triangle TOC. According to the Pythagoras theorem, in the right orange triangle TOC, by PT, we get that CO square equals to OT square plus TC square. Repeat again, according to the Pythagoras theorem, in the right orange triangle TOC, CO square equals to OT square plus TC square. So CO square equals to OT square. OT is R, therefore OT square is R square plus TC square. TC equals to X, that is the line segment that we are looking for, therefore TC square is X square. So in conclusion, we found out that according to equation number 3, CO square equals to R square plus X square. And finally, we'll join points D and O together by a straight line. And we'll implement the Pythagoras theorem in the right pink triangle MOD. According to the Pythagoras theorem, DO square equals to MO square plus DM square. So DO square equals to MO square. MO is R, therefore MO square is R square plus MD square. MD equals to 35, therefore MD square is 35 square. So in conclusion, we found out that according to equation number 4, DO square equals to R square plus 35 square. In the next step, I will copy the 4 equations that we created for the Pythagoras theorem in a new page, in this new page. So here we have, according to equation number 1. We actually found out that AO squared equals to R squared plus 33 squared. And according to equation number 2, we found out that BO squared equals to R squared plus 85 squared. According to equation number 3, we found out that CO squared equals to R squared plus X squared. Finally, according to equation number 4, we found out that DO squared equals to R squared plus 35 squared. Okay. In the next step, I will copy this rectangle if it's circled inside it in a new page, and we will analyze the rectangle with the circle that it is in it. So here we have rectangle ABCD. So this is rectangle ABCD that I copied from the original drawing. We have the circle inside rectangle ABCD. So the center of this circle is at this point, point O. From the center of this circle, that is to say from point O, we draw perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as T, and we know that side AD is parallel to side BC. Therefore, the perpendicular from point O to BC must also be perpendicular to AD. Why? Because side AD is parallel to side BC. Okay, so this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to what I mentioned here. We define the touching point of the perpendicular from point O to AD as M. In the next step, from point O, we go perpendicular on AB. usually this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to construction. We define the touching point of the perpendicular from point O and AB is point S. Again, because of the fact that side AB is parallel to side DC, it means that the perpendicular from point O to AB must be also perpendicular to DC. That is to say, if we extend the perpendicular in such a way that it will touch DC, it must be also perpendicular to DC. Why? Because side AB is parallel to side DC. So here, this angle equals to 90 degrees, and this angle equals to 90 degrees. Why? Because if you have two straight lines that are parallel to each other, then if you have another third straight line that is perpendicular to one of the straight lines, then it must be also perpendicular to the other straight line. Okay. We know that all the angles inside the rectangle are right angles, so this angle equals to 90 degrees. This angle it is equal to 90 degrees. This angle equals to 90 degrees. And finally, this angle also equals to 90 degrees. Inside quadrilateral ASMO, we have 1, 2 rectangles. The sum of rectangles is 270 degrees, plus the size of the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Why? Because 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. So, therefore, usually inside quadrilateral ASMO we have 4 right angles. Therefore, we can relate to quadrilateral ASMO as a rectangle. Likewise, in quadrilateral MOD, here we define the touching point of the perpendicular from point O to DC as point N. So in quadrilateral MODN, we have 1, 2 rectangles. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that I mentioned 1 minute ago. Therefore, quadrilateral MODN that has 4 right angles, it is a rectangle. Likewise, in quadrilateral SBOT, we have 1, 2 right angles. Therefore, the fourth angle must be also equal to 90 degrees, and therefore quadrilateral SBOT is a rectangle. And finally, inside quadrilateral OT and C, we have 1, 2 right angles. Therefore, the fourth angle must be also equal to 90 degrees, and therefore quadrilateral OT and C is a rectangle. So actually found out that inside the big rectangle ABCD, we have 4 small rectangles. Okay, all the 4 quadrilaterals here are rectangles. Okay, so in the next step, we define side AM as H1, we define side MD as H2, we define side AS as B1, and we define side SB as B2. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ASMO, AM equals to SO, but we know that AM equals to H1, therefore SO must be also equal to H1. Likewise, side AS must be equal to side MO, according to the rule that the opposite sides of a rectangle are equal to each other, but we know that AS equals to B1, therefore MO must be also equal to V1. Likewise, in this rectangle MODN, MD equals to ON, but we know that MD equals to H2, therefore ON must be also equal to H2. And also MO must be equal to DN, but we know that MO equals to V1, therefore N must be also equal to V1. Likewise, in rectangle SBOT, SO must be equal to BT, but we know that SO equals to H1, therefore BT must be also equal to H1. And we also know that side SB must be equal to side OT, but we know that SB equals to B2, therefore OT must be also equal to B2. And in rectangle OT and C, we know that ON equals to TC, but we know that also that ON equals to H2, therefore TC must be also equal to H2. And finally, in rectangle OT and C, side OT must be equal to side NC, but we know that side OT equals to B2, therefore side NC must be also equal to B2. In the next step, we will join points O, A and O together by a straight line. And we implement the Pythagoras theorem on the right triangle, triangle ASO. On the right green triangle, triangle ASO. According to the Pythagoras theorem, AO squared equals to H1 squared plus B1 squared. Repeat again in the right green triangle ASO, AO squared equals to H1 squared plus B1 squared. Likewise, we join points O and B together by a straight line. And in the right yellow triangle, triangle OSB, the right green triangle, right yellow triangle, BO squared equals to H1 squared plus B2 squared. Repeat again in the right yellow triangle OSB, BO squared equals to H1 squared plus B2 squared. We join points O and C together by a straight line. So, in the right orange triangle OCT, according to the Pythagoras theorem, we get that CO squared equals to h2 square plus b2 square. Repeat again, in the right-orange triangle OCT, CO square equals to h2 square plus b2 square, and finally we join points O and D together by a straight line. And we'll implement the Pythagoras theorem on the pink right triangle DMO. In the pink right triangle DMO, according to the Pythagoras theorem, we get that dO square equals to h2 square plus b1 square. So we created here another 4 formulas, 4 equations for AO square, BO square, CO square, and DO square. So in the next step, we'll create another 4 formulas or another 4 equations according to the first equation. AO square according to this equation number 1 must be equal to AO square according to this equation number 2. So AO square according to this equation is R square plus 33 square. And it must be equal to AO square according to this equation number 2, that is equal to H1 square plus B1 square. So in conclusion, according to equation number 1, we found out that R square plus 33 square equals to H1 square plus B1 square. In the next step, we'll create equation number 2. And according to equation number 2, BO square according to this equation number 1 must be equal to BO square according to this equation number 2. So BO square according to this equation number 1 equals to R square plus 85 square. And it must be equal to BO square according to this equation number 2, that is equal to H1 square plus B2 square. So in conclusion, we found out that according to equation number 2, R square plus 85 square equals to H1 square plus B2 square. In the next step, we create equation number 3 that states that CO square according to this equation number 1 must be equal to CO square according to this equation number 2. So CO square according to this equation number 1 is R square plus X square, and it must be equal to CO square according to this equation number 2, that is equal to H2 square plus B2 square. So according to equation number 3, we found out that R square plus X square equals to H2 square plus B2 square. finally, we create here equation number 4 that states that d all square according to this equation number 1 must be equal to d all square according to this equation number 2. So d all square according to equation number 1 is r square plus 35 square, and it must be equal to d all square according to this equation number 2. That is actually equals to h1 square plus b1 square. It's actually b1 square plus h2 square. Again, it is b1 square plus h2 square. So in conclusion, according to equation number 4, we found out that r square plus 35 square equals to h2 square plus b1 square. Okay, so in the next step, we subtract equation number 1 from equation number 2. Which is 2 minus 1. In this way, we create equation number 5. So in equation number 2, we have to decide r square plus 85 square minus equation number 1. Here we have r square plus 33 square. And here we go to the other side of equation number 2, so it is equation number 2 minus equation number 1. In the other side of equation number 2, we have h1 square plus b2 square minus equation number 1. In the other side of equation number 1, we have here minus h1 square plus b1 square. Okay. So here we will open the brackets of this equation number 5, and we will get that according to equation number 5, r square plus 85 square minus r square minus 33 square equals to h1 square plus b2 square minus h1 square minus b1 square. So in this side of equation number 5, we have r square minus r square is 0, so r square will get cancelled. And the other side of this equation number 5, we have b. We have here h1 square minus h1 square, that is 0, so h1 square will also get cancelled. In conclusion, found out that according to equation number 5, 85 square minus 33 square is equal to b2 square minus b1 square. Okay. In the next step, we subtract equation number 3 from equation number 4, which is 4 minus 3. we'll get here equation number 4, we have here in this side of equation number 4 r squared plus 35 squared minus equation number 3, we have in this side r minus r squared plus x squared. That is equal to, move to the other side of equation number 4, so we have here h2 squared plus b1 squared minus this side of equation number 3, we have minus h2 squared plus b2 squared. In the next step, we'll open the brackets of this equation number 6, and we get that according to equation number 6, r squared plus 35 squared minus r squared minus x squared equals to h2 squared plus b1 squared. Here we have minus h2 squared minus b2 squared. So in this side of equation number 6, we have r squared minus r squared, that is 0, so r squared will get cancelled. In the other side of equation number 6, we have h2 squared minus h2 squared, so h2 squared will also get cancelled. And finally, we found out that according to equation number 6, 35 squared minus x squared equals to b1 squared minus b2 squared. In the next step, we multiply this equation number 6 by minus 1, and we get, according to equation number 6, minus x squared times minus 1 is plus x squared, 35 squared times minus 1 is minus 35 squared, and it is equal to minus b2 squared times minus 1 is plus b2 squared, and b1 squared times minus 1 is minus b1 squared. So in conclusion, we found out that according to equation number 6, x squared minus 35 squared equals to b2 squared minus b1 squared. In the next step, we'll create equation number 7 that states that b2 squared minus b1 squared according to equation number 5 must be equal to b2 squared minus b1 squared according to equation number 6. So b2 squared minus b1 squared according to this equation number 5 is 85 squared minus 33 squared, and it must be equal to b1 squared minus b2 squared according to this equation number 6, and found out that b2 squared minus b1 squared according to this equation number 6 equals to x squared minus 35 squared. So in conclusion, found out that according to equation number 7, 85 squared plus 33 squared equals to x squared plus x squared minus 35 squared. Here we will add 35 squared to this equation number 7, and we get that according to equation number 7, 85 square plus 35 square minus 33 square equals to x squared. So according to equation number 7, 85 squared is 7,225 plus 35 squared. 35 squared is 1,225 minus 33 squared. 33 squared is 1,089. So it is minus 33 squared. It is minus 1,089. It is equal to x squared. So here 7,225 plus 1,225 is 8,450 minus 1,089 equals to x squared. And 8,450 minus 1,089 equals to 7,361. This is equal to x squared. So according to equation number 7, we found out that x squared equals to 7,361. Here we take out of this equation, equation number 7, and we will get that according to equation number 7, x equals to plus minus the square root of 7,361. Okay, so here we have two solutions that are possible for x, the positive solution and the negative solution. But because of the fact that x is a length, it must be a positive number. So we take into account only the positive solution. That is to say, here x will be equal to the positive square root of 7,361. That is actually equals to 85.796 units. So we actually found out that the length of line segment x, here the length of this line segment x equals to 85.798 units. I finished with the first question. In the next step I will present to you the second question, and we will solve the second question in two different methods. So in the drawing we have a semicircle. We know that AB equals to 6 units. AB is the diameter of the semicircle, that is equal to 6 units. We also know that this angle CAB equals to 30 degrees, and our mission is to find out the area of the green shape. So first of all, we define the center of this semicircle as O. We know that the diameter of this semicircle AB equals to 6 units. Therefore, the radius must be equal to half of it. That is to say, the radius AO equals to 6 over 2. That is 3 units. So AO equals to 3 units, and the radius OB is also equals to 3 units. We join points O and C together by a straight line. Here, point O is the center of the semicircle, point C is the point on the semicircle itself. Therefore, OC is the radius of the semicircle that is equal to 3 units. In triangle AOC, this triangle, AO equals to 3 units, OC equals to 3 units, therefore they are equal to each other. And we know that in front of equal sides in the triangle, they are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees. Therefore, this angle must be also equal to 30 degrees. So inside triangle AOC, this angle equals to 30 degrees, this angle equals to 30 degrees. 30 degrees plus 30 degrees is 60 degrees. And we know that the sum of the angles in any triangle is 180 degrees, therefore the missing angle must be equal to 120 degrees. Okay. In the next step, I will explain to you how to find out the area of a sector. So here we have sector this is sector A or OAB, and the sign for the area of a sector AOB is the rounded sign above OAB. This is the sign of the area of sector AOB. The rounded sign is the sign for the area of a sector. So the area of this sector OAB will be equal to the area of the circle that contains the sector. That is to say it is pi r square. Here OA equals to r, the radius. OB also equals to r, that is the radius of the circle that contains the sector. So it is the area of the circle times theta over 360 degrees. Theta is the angle between the legs of the sector, the angle between AO and OB. So here I'll explain you what is the meaning of this formula. The ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the entire circle, and when we will multiply this relative percentage by the area of the entire circle that is pi r square, we will get exactly the area of this sector AOB. Okay? So we'll use this formula in order to find out the area of sector AOB. So I'll copy sector AOB in the new page and we'll use the new formula in order to find out the area of sector AOB. It is actually sector AOC, this sector. So actually, this is sector AOC that I copied from the original drawing. So according to the formula that I presented to you, the area of this sector AOC will be equal to pi r square. R is the radius of the circle that contains the sector, and we know that the radius of the semicircle that contains sector AOC is 3 units. So r equals to 3, therefore pi r square is pi times 3 squared. Theta is the angle between the legs of the sector AOC, and it is equal to 120 degrees over 360 degrees. Okay, so here three square is 9, so this expression in total equals to 9 pi. 120 degrees over 360 degrees is 1/3, so it is 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So in conclusion, we found out that the area of sector AOC equals to 3 pi square units. Okay. In the next step, I will present to you a new formula for the area of any triangle. So here, if we have here a triangle ABC, that could be any triangle. This is triangle ABC. We know that the length of side AB of this triangle ABC, is equal to A units. The length of side AC is B units, and the angle between side AB and side AC is theta. Then, according to the new formula, the area of this triangle ABC, will be equal to A times B times sinus theta over 2. Okay. We'll use this formula in order to find out the area of triangle AOC. So I'll copy this triangle AOC in this new page, and we'll use the new formula in order to find out the area of this triangle AOC. So actually, this is triangle AOC that I copied from the original drawing. According to the new formula, the area of this triangle AOC will be equal to AO times OC, or OA times OC, times sinus 120 degrees over 2. So OA is 3, OC is also 3, sinus 120 degrees is equal to 3 over 2, all divided by 2. 3 times 3 is 9, so it is 9 times square root of 3 over 2 times 2 is 4. So in conclusion, we found out that the area of triangle AOC is equal to 9 times square root of 3 over 4 square units. And we have already found out that the area of sector AOC, the area of sector AOC is equal to 3 pi square units. But what is actually the area of the green shape? From the drawing, it is very easy to see that the area of this green shape will be equal to the area of sector AOC minus the area of triangle AOC. Repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC, that is equal to 9 times square root of 3 over 4 square units. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. So we finished with the first method. The next step I will present to you how to find out the area of this green shape according to the second method. So according to the second method, the area of this green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. I'll repeat again. According to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. So what is the area of the semicircle? The area of the semicircle equals to the area of the circle, that is pi r square over 2. We know that r equals to 3 units, therefore pi r square is pi times 3 square over 2. 3 square is 9, so in total this expression equals to 9 pi over 2. So in conclusion, we found out that the area of the semicircle equals to 9 pi over 2 square units. Okay. And we have already found out in the first method that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. The only thing that is left to find in order to find out the area of the green shape according to the second method is to find out the area of sector COB. In order to find out the area of sector COB, we will find out the angle between its legs. AB is the diameter of the semicircle, therefore AB is a straight line. If you focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have here? This angle equals to 120 degrees plus the missing angle. In total, they must be equal to 180 degrees. That is the sum of the angles on one side of a straight line. So the missing angle here must be equal to 60 degrees in order to complete the sum of the angles on the upper side of AB at point O to 180 degrees. This angle must be equal to 60 degrees. So I found out that the angle between the legs of sector COB is 60 degrees. In the next step, I will copy sector COB in a new page and we'll calculate the area of this sector, sector COB, according to the new formula for the area of any sector. So here sector COB. So the area of this sector, sector COB, and I call it from the original drawing, according to the formula for the area of any sector, the area of any sector equals to pi r squared times theta over 360 degrees. We use this formula in order to find out the area of sector COB. According to this formula, the area of sector COB equals to pi r squared. R is free, so pi r squared is pi free squared times theta over 360 degrees. Theta is the angle between the legs of sector COB. The angle between the legs of sector COB is 60 degrees. So it is 60 degrees over 360 degrees. So in conclusion, we found out that the area of sector COB equals to pi free square. Free square is 9, so in total this expression equals to 9 pi. And 60 degrees over 360 degrees is 1 over 6. So here we divide both the numerator and the denominator by 3. 9 over 3 is 3, so in the numerator we have 3 pi over 6 over 3 is 2. So in conclusion, we found out that the area of sector COB is equal to 3 pi over 2 square units. Okay. Again, what is the area of the green shape? According to the second method, I already mentioned that the area of the green shape according to the second method is equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again. According to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of the triangles AOC equals to 9 times 4 to 3 over 4 square units. And finally, we have already found out just right now that the area of sector COB equals to 3 pi over 2 square units. 9 pi over 2 minus 3 pi over 2 is 6 pi over 2 minus 9 times 4 to 3 over 4. 6 over 2 is 3, so in conclusion found that in total this expression equals to 3 pi minus 9 times 4 to 3 over 4 square units. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times 4 to 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. So in the next step, we'll summarize the lecture. We'll start with the first question, of course. So in the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have a circle. We know that the tangent from point A to this circle is 33 units in its length. The tangent from point B to this circle is 85 units in its length. The tangent from point C to this circle is the tangent that we are looking for. It is unknown, so it is equal to x, and we have to find out the value of x. And finally, the tangent from point D to this circle equals to 33 units in its length. Again, our mission is to find out the value of x. So here we know that the radius OE is drawn to the point of tendency, therefore this angle equals to 90 degrees according to rule number 1. The radius OM is drawn to the point of tendency, therefore this angle also equals to 90 degrees. The radius OT is also drawn to the point of tendency, therefore this angle equals to 90 degrees. And the radius OF, it is drawn to the point of tendency, therefore this angle equals to 90 degrees. Then we join points A and O together by straight line. This way we created the green triangle AOE according to the Pythagoras theorem. And the green right triangle AO square equals to EO square plus AE square. Okay, again, the green right triangle AO square equals to OE square plus AE square. AE equals to 33, EO equals to R, therefore AO square equals to R square plus 33 square. Only to equation number 1. Then we joined points B and O together by a straight line. In this way we created the right triangle, the right yellow triangle OBF. According to the Pythagoras theorem, in the right yellow triangle OBE, BO square equals to OF square plus FB square. Again, OB square equals to OF square plus FB square. BF is 85, OF is R, therefore OB square, that is equal to OF square plus BF square, it is actually OB square equals to R square plus 85 square. Then we joined points O and C together by a straight line. In this way we created the right orange triangle OTC. According to the Pythagoras theorem, CO square equals to OT square plus TC square. Okay, again, according to equation number 3, CO square equals to OT square plus TC square. OT is R, TC is X. Therefore, according to equation number 3, we found out that CO square is R square plus X square. Then we joined points A and O and D together by a straight line. We created the Pythagoras theorem. In the right pink triangle, triangle MOD. According to the Pythagoras theorem, DO square equals to MO square plus MD square. Repeat again. DO square equals to MO square plus DM square. MO is R, MD is 35. Therefore, DO square equals to R square plus 35 square. Then I copied the four equations that we created according to the Pythagoras theorem in a new page. And then I copied rectangle ABCD here with its circle inside. Then actually from point O, that is the center of the circle, we draw perpendicular on AB. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. But because of the fact that side AB is parallel to side DC, it means that the perpendicular to AB must be also perpendicular to DC. Why? Because AB is parallel to DC. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to the reason that I mentioned. Then from point O, we go perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. But because of the fact that side AD is parallel to side BC, therefore the perpendicular to BC must be also perpendicular to AD. So this angle equals to 90 degrees and this angle also equals to 90 degrees because of the reason that I mentioned. Because AD is parallel to BC. Okay. So we know that all the angles inside the rectangle are right angles, so those four angles are right angles. So here in quadrilateral SBOT, we have 1, 2, 3 right angles. Therefore, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. The same thing is true for all the three other quadrilaterals. We have 3 right angles in each quadrilateral. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So, we have 4 quadrilaterals, that each quadrilateral has 4 right angles, therefore all the quadrilaterals are rectangles. Why? Because any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to all 4 quadrilaterals as rectangles. And we know that the opposite sides of a rectangle are equal to each other. We define BT as edge 1, TC as edge 2, SB is B2, and AS is B1. Okay? And according to the rule that the opposite sides of a rectangle are equal to each other, so in rectangle SBOT, this is B2, therefore this side must be also equal to B2. Here, this side is edge 1, therefore this side must be also equal to edge 1. And the same thing is true for all the other 4 rectangles. In rectangle ASMO, SO is edge 1, therefore AM must be also equal to edge 1. AS is B1, therefore MO must be also equal to B1. According to the rule that the opposite sides of the rectangle are equal to each other. In this way we found out actually the values of all the sides of those 4 rectangles. Then we join points A and O together by a straight line. According to the Pythagoras theorem, on the green right triangle, h1 square plus b1 square equals to AO square. In the yellow right triangle, BO square equals to B2 square plus h1 square. In the orange right triangle, CTO, B2 square plus H2 square equals to CO square. In the pink right triangle, BOM, h2 square plus b1 square equals to do square. So in this way we created four equations. So we have two expressions for AO square, we have two expressions for BO square, two expressions for CO square, and two expressions for DO square. Then we created equation number 1 that says that AO square according to equation number 1 must be equal to AO square according to equation number 2. Then we created equation number 2 that says that BO square according to this equation number 1 must be equal to BO square according to equation number 2. Then we created equation number 3 that states that CO square according to this equation number 1 must be equal to CO square according to equation number 2. And finally we created equation number 4 that states that DO square according to this equation number 1 must be equal to DO square according to this equation number 2. In this way we created those four equations. Then we subtracted equation number 1 from equation number 2, and in this way we created actually equation number 5 that states that 85 square minus 33 square equals to b2 square minus b1 square. Then we subtracted equation number 3 from equation number 4. We got equation number 6. And according to equation number 6, we found out that x square minus 35 square equals to b2 square minus b1 square. Then we created equation number 7 that says that b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. So this is equation number 7. 85 square minus 33 square equals to x square minus 35 square. We added 35 square to this equation number 7, and found out that 85 square plus 35 square minus 33 square equals to x square. 85 square is 7,225, plus 35 square is 1,225, minus 33 square is 1,089. That is equal to x square. 7,225 plus 1,225 is 8,450 minus 1,089 equals to x square. 8,450 minus 1,089 is 7,361. That is equal to x square. Then we took a root out of this equation number 7, and found out that x equals to the plus minus square root of 7,361. So here we have two solutions that are possible for x. But because of the fact that x is a length, x as a length must be a positive number, so we take into account only the positive solution. That is to say, x, the line segment that we are looking for, equals to 85.796 units. So we finished with the first question, then I presented to you the second question, and we solved the second question in two different methods. So in the drawing, we have a semicircle. You know that the diameter of this semicircle AB equals to 6 units. Angle CAB equals to 30 degrees, and our mission is to find out the area of the green shape. So we define the center of this circle as O. The diameter of this semicircle is 6, therefore the radius must be equal to half of it. That is to say, the radius of this semicircle will be equal to 6 over 2, that is 3. That is to say, the radius AO is 3 units, the radius OB equals to 3 units. Point O We join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point of the semicircle itself. Therefore, OC is the radius of this semicircle, that is equal to 3 units. Then, in triangle AOC, side AO equals to 4 units, side OC equals to 4 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. We also know that the sum of the angles in any triangle is 180 degrees, so this angle equals to 30 degrees, this angle equals to 30 degrees. 30 degrees plus 30 degrees is 60 degrees, therefore the missing angle must be equal to 120 degrees. Then I presented to you the formula for the area of any sector. So if we have this sector, sector A or B, that could be any sector, know that OB equals to R, AO equals to R, and the angle between the legs of the sector is theta. Then the area of this sector, sector OAB, first of all, this is the sign for the area of sector AOB, the rounded side above AOB is the sign for the sector, so it is sector OAB, the area of this sector, sector OAB, equals to pi r squared times theta over 360 degrees. Theta is the angle between the legs of the sector. R is the radius of the circle that contain the sector. So here the ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the entire circle, and when we will multiply this relative percentage by the area of the entire circle, that is to say pi r square, we get exactly the area of the sector, sector OAB. So theta over 360 degrees times pi r square will give us exactly the area of this sector, sector AOB. Then we use this formula in order to find out the area of this sector, sector AOC. So I copied sector AOC here, and we use the new formula in order to find out the area of this sector, sector AOC. The angle between the legs of the sector is 120 degrees, and each leg of this sector is 3 units, that is actually the radius of the semicircle. So pi r squared, r is 3, so pi r squared is pi times 3 squared. The angle between the legs of the sector is 120 degrees, so theta is 120 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi. 120 degrees over 360 degrees is 1/3. So in total this expression equals to 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So we found out that the area of this sector, sector AOC, equals to 3 pi square units. Then I presented to you a new formula for the area of any triangle. Here we have this triangle ABC that could be any triangle. The length of side AB is A units, the length of side AC is B units, and the angle between side AB and side AC is theta. Then, according to the new formula, the area of this triangle, triangle ABC, will be equal to A times B times sinus theta over 2. Then we use the new formula in order to find out the area of this triangle, triangle AOC. So I copied triangle AOC here, and we use the new formula to find out the area of this triangle, triangle AOC. AO equals to 3, OC equals to 3, and the angle between side AO and side OC is 120 degrees. So the area of this triangle, triangle AOC, according to the new formula, will be equal to AO times OC times sinus 120 degrees over 2. AO is 3, OC is 3, sinus 120 degrees is equal to 3 over 2, all divided by 2. 3 times 3 is 9, so in the numerator we have 9 times square root of 3 in total. in the denominator we have 2 times 2, that is 4. So in conclusion, we found out that the area of triangle AOC equals to 9 times 4 to 3 over 4 square units. We have already found out that the area of sector AOC equals to 3 pi square units. What is the area of the green shape? Actually, it is very easy to see from the drawing that the area of this green shape equals to the area of sector AOC minus the area of triangle AOC. Again, the area of sector AOC minus the area of triangle AOC will give us exactly the area of the green shape. Repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, so in terms of numbers, it is equal to 5.53 square units. We finished with the first method, then I presented to you how to find out the area of this green shape according to the second method. According to the second method, the area of this green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of triangle minus the area of sector COB. What is the area of the semicircle? The area of the semicircle equals to the area of the circle over 2. That is to say, it is pi r square over 2. R is 3, so pi r square is pi 3 square over 2. 3 square is 9, so in total this expression equals to 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out in the first method that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. The only thing that is left to find is to find out the area of sector COB. In order to find out the area of sector COB, we have to find out the angle between the legs of sector COB. AB is the diameter of the semicircle, therefore it is absolutely a straight line. If you focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees. According to rule number 3. So which angles we have? In the upper side of AB at point O, we have this angle that is equal to 120 degrees, plus the missing angle. In total, they must be equal to 180 degrees. So the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees. Then I copied sector COB in a new page, and we find out the area of this sector according to the new formula. This is sector COB, that I copied from the original drawing. We know that the area of any sector is equal to pi r squared times theta over 360 degrees. Theta is the angle between the legs of the sector. R is the radius of the circle that contains the sector. We know that R is the radius of the semicircle that is equal to 3 units, and the angle between the legs of this sector is 60 degrees. Theta is 60 degrees. So here pi r square is pi 3 square, theta is 60 degrees over 360 degrees. 3 square is 9, so in total this expression equals to 9 pi. 60 degrees over 360 degrees is 1 over 6. So in total we found out that the area of sector COB equals to 9 pi over 6 square units. We divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3, so in total in the numerator we have 3 pi. 6 over 3 is 2. So in conclusion, we found out that the area of sector COB equals to 3 pi over 2 square units. Now we can find out the area of the green shape according to the formula that the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle is 9 pi over 2 square units. We have already found out that the area of the triangle AOC is 9 times square root of 3 over 4 square units, and we just found out that the area of sector COB equals to 3 pi over 2 square units. 9 pi over 2 minus 3 pi over 2 is 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi. So we found out actually that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, so in terms of numbers it is equal to 5.53 square units. Okay, thank you very much.